Hello, everyone. This is Moeen Mostafavi, PhD student in System and Information Engineering at the University of Virginia. Today, I present one of our collaborative work entitled Collision Prediction and Prevention in Contact Sports using RFID tags and haptic feedback. Let me start with motivation behind this project. Although the risk of impending injury in contact sports is high, those sports are prevalent. For example, over 1 million high school students and 70,000 college students play American football. Unanticipated hits in the game causes extreme injuries because players are unprepared for the hits. Researchers estimated about 4 million concussions occur in the United States during sports every year. American football is a leading sport for contact-related injuries such as cervical spine injuries resulting from an unforeseen hit. The use of a feedback mechanism to alert a player of a potential hit may mitigate the risk for sport-related concussion and catastrophic injury by allowing them to brace for an otherwise unforeseen impact effectively. This project introduces a proximity sensor system using radio frequency identification or RFID to predict incidents and send haptic feedback to players before a potential impact. To predict and prevent collisions, we designed a system that consists of a wireless tracking system, haptic feedback, and the central server to detect impending severe collisions. The hardware for the tracking system is based on Visor redundant radio localization and tracking system, which has a set of RFID tags that you can see as element D in the left picture. These tags can be placed anywhere on the player's body. It has also 4 antennas that track the tags in the field. These antennas are element B on the left picture. The players carry tracking tags and the system provides up to 12 Hz sampling rate. These tags are tracked in real time using a set of antennas. In this project, we installed 4 antennas in the corner of the game field, and the 5th one, which was connected to the server, was located along the half-court line. The blue stars on the right picture can show places to install the antennas. For the haptic feedback, we used an interface transmitter from LRS paging system. The transmitter is shown on the left side of the picture. Its pagers on the right side of this slide provides a vibration stimulus to the player who are projected to be in a severe collision. Every time an incident was anticipated, the players received a vibration and blinking LEDs of the pager made it visible to other people. The TX7470C232 interface uses COM port to transfer the data using the terminal to the computer or to the server. The 5th antenna of the RFID connects the server computer using a USB port. In this short API is sending tracking data to MATLAB. MATLAB sends the vibration commands to the pagers. The data is transferred to the local host in JSON format. To process the data, MATLAB imports the data from the local host, then analyzes in real time to send feedback. For future analysis, the data is stored on the server computer, and the pilot test was video capture. Initially, we implemented the system in a large office, and the server program only stored the data without any processing. We processed the data offline in MATLAB. The GUI platform shown in this video, it was used to simulate the tracking system under different scenarios. The blue circles represent the two participants. One participant carried one tag and the other participant carried two tags that are shown by smaller black circles around the blue circle. Their average location is the location of the participant, which is shown by the blue circle. As you can see, we could see the timestamp each sensor transmitted data and the estimated and actual distance of the participants. When an incident was predicted, we could observe the larger circle around the players. Using the knob slider and other interfaces, we could repeat the simulation under different scenarios, and we discussed in the paper how these scenarios helped us to tune the system parameter. After installing the antennas at the corners of a basketball court, we implemented the system in the field. In this short video, we can observe when one player approaches the other player, the pager system vibrates and blinks, showing potential incident. Here, we had sampling rate limitation for the devices we used. So the participant in this test didn't run fast. By updating the RFID system, it's possible to collect data with higher sampling rate, and the system can be used in real time in, for example, football games. To verify the use of this system, we use NFL data for a simulation and predict potential incidents. NFL worked with a third party to install RFID tags in the player's shoulder pads to collect tracking data for a kind of contest by NFL called Big Data Bowl. They released tracking data for 2017 games. To validate our collision detection algorithm, we use data generated from NFL games. We use this data for simulating our algorithm in a real game. In the simulation on the left side of the screen, players would have circles appearing around the area that collisions are anticipated. Let's view this part of the game from YouTube. So. You can see it, and it's possible to compare all the incidents in all the actual incidents in the game and anticipated ones. We considered location estimation in two different approaches. In the first approach, the speed and orientation of the players are given in real time. And in the second approach, the players have constant speed between two samples. And we estimated the speed and location ourselves. The real data and the two approaches in a less than 15-second game simulation are shown in this table. This table comes from the part of the game that we have seen in the previous slide. There are 6 major incidents when the threshold of incidents is 2 feet distance between players. Considering a constant speed between two samples, we can predict all these incidents plus a false alarm for an incident in 28 frames. For the first actual incident, the fixed speed results in 0.4 second error for incident time, but all other 5 incidents are accurately estimated. So this approach, in this approach, we have only 14% false alarm. Using even speed and orientation from NFL data, we have 4 false false alarm and 2 incidents are missed. Okay, so so far we have seen that we have a novel framework to predict concussion injuries during a game and send haptic feedback to minimize the risk of these incidents. If you have any question about this project, or if you need, for example, codes that we wrote in MATLAB or R, or anything else about this project, please feel free to reach out to me. Thank you so much for listening to this presentation, and have a wonderful one.